enter. Make sure plot 1 is turned off for now. We're not going to need that until later. We type this in. Oh, before we do that, okay? Guys, the exam is just going to have a functions section, functions in general. What type is this? What do we call this one? Linear, quadratic, or cubic? It's linear, right? Okay, what is the leading coefficient? It's this. This is what we call A. So this is negative. What do we know in terms of the behavior of this line? Does it go up or down from left to right? It'll go down. And so sometimes students think, oh, it's going to go down like that. But sometimes it goes down very, very slowly, right? The slope is very, very, like it's not a steep decline. It's just a shallow decline. But nonetheless, this is what we expect. And behavior goes from quadrant 2 to quadrant 4. My y-intercept, what is my y-intercept in this one? This is what we call b, right? That's the constant. So my y-intercept is 0, 12.35. All of these things we know already. So what does that mean? I expect it to start at 12.35, and then it will go down from there. Does that make sense? That's what I want you to start thinking of over and over again. So let's type that in. 12.35. Watch for, don't miss any zeros. Nothing like that, okay? So let's hit graph. That's what I see. It looks like a straight line. Maybe for now you want to keep it this way. If you're trying to find the x-intercept, you're going to travel for a very, very long time. That's my guess. Customize your window to check out. Let's explore a little bit. X max, I'm going to go, is this the one we were doing, Danica? Let's go 2000 for my X max. Oh, it crosses, right? So it was overkill. Guys, listen carefully to this part. This is my y-axis. When I set X max to 2000, that represents the end here. This is 2000. I don't need that much. I can go to 1000 or probably 800. So back to window. I'm going to change that to 800. That is a pretty good window right there. I would be okay with that. You see your y-intercept, you see your x-intercept. Now, please listen carefully to this part. If you're going to use the zoom features, and let's say you try zoom fit. Oh, it actually did a pretty good job. I'm going to go back to standard, okay? Standard zoom, you don't see a thing. Why is that? Because this is 10. So you're starting at 12 and going slowly, you're going dropping, right? So if you go zoom fit, pay attention to this part. This is the one. Actually does a pretty good job. But it's notorious for, if you press window, it doesn't change your y or x min to be negatives. I want it to be somewhat negative. So I'm going to change my y min to -5 or something like that. X min, y min, I want to make sure they're negative. Because that way I will see the axes, right? So make sure you do that. You change your x min to negative and your y min to a negative, and then chase the curve going into the x max or y max from there. X max, y max, right? So I already determined that a good x max is what, 800 did I say? Yeah. So if x max is 800, I can actually see it going down to the x-axis. This is a pretty good graph. Let's answer some questions. What type of function is this? It's linear, degree of 1, okay? What voltage is produced after the battery has been used for 3.75 hours? And remember, V is the voltage and H is the hours. And remember, H is our, this is very important actually, you need to make sure, H is our X value, so that represents our hours. And V is the Y variable, that's voltage. Please don't mix that up, okay? So what is it giving us, X or Y? It's giving us X, so it's saying if the time is 3.75 hours, what is the voltage? We're gonna go second, trace, value, X is equal to 3.75, and we're gonna find out Y. Second trace value, 3.75. And it's still way up there, but we don't worry about it too much. We're gonna go by this 12.23. And what is our unit? Volts, right? It says voltage and volts. So just write volts next to it and circle it. That is your answer. Okay? Yeah. Yes. Yes. So if you just plug 0 in here, 3.75 and then calculate it, that works. C. If the battery must be replaced. Is that a bus, the bus thing? Evacuation. 11.8 volts, when it drops below that, it's no longer good. It stops working. Did you know that, by the way? That your batteries start at a certain voltage? Like this one is 9, right? And as you start using it, it's going to drop. That's why your devices stop working, because the voltage drops over time. And so in this case, we want to know how long will it take to get to 11.8. We start at 12.35. We drop to this. Okay, so how do we do this? Y2 is 11.8. Second, trace, intersect. So we will find that, 11.8. We graph it. It's right at the top here. Second trace, intersect. Enter, enter, enter. And it happens after 17.74 hours. 17.74 hours is the answer. So quite some time until the battery no longer works. State the domain and range of this scenario. Use the results in C to answer this. My domain, we're talking X values, right? Pay attention to this one, right? We're going from here, and then it stops working here. So we are at 0, 12.35. That's something that we never found, but you're supposed to know that just by looking at the equation. And then this happens at 17.74. And what is the voltage at that point? 11.8. So I'm going to zoom into that part. So our domain and range is restricted on both ends. So domain, we start at 0, and where do we stop in terms of my X values? 17.74. Boom, right? In terms of range, I start as low as, what's the lowest voltage? 11.8. And the highest voltage? 12.35. Because you can't have negative time, right? So we're assuming that we start there. We don't consider this part. Okay, so that's that. And now the graph, that's the one you were struggling with, right? So let's label first. This is time in hours, right? And this is voltage in volts. Okay? I need to, guys, this is my sketch, this is my rough draft before I complete this. I need to make sure I go all the way up to 17.74. So 5, 10, 15, 20. That'll do it for me. Sorry, what happened there? 10, 15, 20. In terms of the Y, what's the highest I need to account for? 12.35. So 2, 4, 6, 8, 10, 12. It's a little tight. 3, 6, 9. I'm going to go with 3, 6, 9, 12, 15, 18. Okay? I'm just going to decide that. I think my key I went up by 2, but that's okay. It doesn't matter as long as you're consistent. So we start at, if this is 12, then this is 13. Right? So 12.35 is somewhere there. And then you need to find your 17. This will be 17 and a half right here. So 17.75 is we're just past it. So I'm going to go up that until it's 11 point. This would be 11. 11 is right about here. So be right about there. That's close enough is good enough. So it stops somewhere there. We would not split hair on that one. If it's approximately where it should go, you're good to go. So in this case, that would be the graph. And then just make sure, if you want full marks, that's what you do. Can I give you a little? No problem. You're not late usually. Can I give you a little heads up on the exam? Most of the time, listen carefully. Most of the time, when you're asked to graph, they will give you all of the points. Like there'll be a table. Like we'll do regressions shortly. Okay, shortly. They'll give you a bunch of points. You just have to make sure you plot them. But not always. They have done this too, where you have to find points and then you graph it. But most of the time, they give you all the points. So how is this going to be different, Mr. Dirksen? If you are given an equation, they'll just ask you a bunch of questions, but they won't necessarily ask you to graph. They'll ask you for domain and range. They'll ask you for how long did it take to run out of battery. They'll ask you those types of things, but graphing, not so much. So just a little heads up, if this gives you anxiety, I would still expect you to be able to graph this if I give you enough information, or if you find it, okay? And so that's that. Any more questions? No? Well, let's see, maybe I can answer it quickly. 2D?
Yeah, for range, I went like 180 to 880. But I don't think it's 880. Like the answer consider is 500.
It stops, right? I'm just going to show you the key. So from here, so why did I stop here? That's what I'm going to try to investigate. Yeah. That's right. So, did you hear that? So it says the company can make a maximum of 1,500 flyers. So if the x-axis represents the number of flyers, you need to stop at 1,500. Like, even though your calculator shows you passed it, for our scenario, we stop here. So the company can make 0 flyers, right? And then keep producing. And because of this statement right there, we stop there. And I did the math. Look at, it's right here. This is why. I did the math. I went second trace value, x is equal to 1,500, and I figured out that y is 555. So I'm going to actually label that. Okay? So that is why I had to, that's why my range goes from here to 555. Does that make sense?
Yeah.
All right.